The Sun is 93 million miles away from us and measures a staggering 865,000 miles across, big enough to fit 1 million Earths inside. It has been studied with great interest for thousands of years, and yet we know very little about it. But humanity is on a mission to touch the Sun, and advanced telescopes are being built on Earth and some sent into space to help us solve the Sun's greatest mysteries. Mankind's greatest inventions are now sending back incredible images of our star as you've never seen it before. Sitting at the center of our solar system is a nearly perfect sphere of burning, sizzling plasma, radiating intense heat and light. Earth resides in the vast atmosphere of the Sun, which creates a complex space environment that sometimes interferes with space technology, communications, navigation systems, and utility grids. If we can predict severe space weather from the Sun in future, it could help us prepare for solar storms, but we need to get closer to understand it. Now, new telescopes on Earth are taking images of the Sun in mind-melting detail. The Daniel K. Inouye Solar Telescope sits on top of a mountain on the island of Maui in Hawaii and is the world's largest sun-spotting telescope. On January 30th, 2020, the telescope snapped some high-resolution images of the Sun showing a pattern of turbulent boiling plasma covering the surface. The hot solar plasma rising in the bright centers of the cell cools off and sinks below the surface in dark lanes, a process called convection. But the Inouye Solar Telescope was just getting warmed up. An image taken on December 11th, 2020 is the most detailed photo of a sunspot that humans have ever seen, showing magnetic structures as long as 12 miles. The sunspot appears as a fiery heart that is 10,000 miles across. That's big enough for the Earth to fit inside. The dark region is a concentration of magnetic fields that block heat within the Sun from reaching its surface. Even though this dark area of the sunspot is cooler than the brighter parts, it's still more than 7,500 degrees Fahrenheit. It was discovered that stretching out from those dark regions thought to be empty are strands of hot electrified gases that stretch out for miles. The amazing images showed that each strand is 1.8 million degrees Fahrenheit. The most incredible thing is that the Inouye Solar Telescope captured this image of the sunspot before the facility was completed, meaning the telescope will be capable of producing even more amazing images using its advanced optics and 13-foot primary mirror. Currently, these are the best images taken of the Sun from Earth, but now there are telescopes out in space that can take even better images. NASA's Solar Dynamics Observatory was launched into geosynchronous orbit above the Earth on February 11th, 2010. It's a cargo van-sized piece of equipment that has three main instruments. The Atmospheric Imaging Assembly, which is a battery of 4 telescopes that are designed to photograph the Sun's surface and atmosphere. The Extreme Ultraviolet Variability Experiment, EVE, that measures the Sun's ultraviolet output, and the Helioseismic and Magnetic Imager, which can map solar magnetic fields and look below the Sun's opaque surface using a technique called helioseismology, studying the Sun by listening to it and observing vibrations on its surface. It's been recording the Sun for over 10 years, and in time-lapse footage you can see an extreme ultraviolet wavelength showing the Sun's outer corona and the rise and fall of the solar cycle. The Sun goes through a solar cycle every 11 years, where it expands and retracts in size. When this happens, the Sun's north and south poles trade places. This cycle has been observed for centuries by changes in the appearance of the Sun itself, as well as phenomena like the northern lights here on Earth. Over the course of this 11-year cycle, activity on the Sun can be observed in a state of synchronized fluctuation, solar flares, coronal mass ejections, sunspots, coronal loops, and even the level of solar radiation are all tied to these 11-year cycles. From planet Earth, the Sun looks like a rather stable celestial body, but as we get closer, we can see the Sun is very volatile. Solar flares occasionally shoot out of the surface, blasting a large cloud of energetic and highly magnetized plasma into space called coronal mass ejections. On July 19, 2012, the ultra-high-definition telescope aboard NASA's Solar Dynamics Observatory captured hours of stunning footage of a solar flare erupting from the Sun, the gigantic arc much bigger than the planet Earth. The compressed footage shows the million-degree plasma begin to cool and fall to the surface, an electrifying magnetic downpour of coronal rain. The charged plasma is strongly influenced by the Sun's magnetic field. As the plasma rained down, it condensed along twisted magnetic field lines close to the surface, forming giant, streaming arcs, some as tall as 5 Earths. On April 17, 2016, the Solar Orbiter captured stunning images of a mid-level solar flare erupting from the surface of the Sun. The amazing footage may help us understand what causes these powerful bursts of radiation. Powerful flares happen all the time, but solar flares aren't always strong enough to create mass coronal ejections of plasma. Most of the time, they show up as bright spots on the surface. But when plasma is kicked out of the Sun, it can be a breathtaking phenomenon. The largest flares could have the potential to cause worldwide blackouts across the Earth if a solar flare big enough were to hit us. And the Earth has almost been hit recently by a solar flare. In November 2020, a very large solar flare erupted from the Sun and narrowly missed the Earth. But there's no need to panic, as this sort of activity isn't happening all the time. And when it does happen, the flare would have to be timed just right. Even though we have the powerful telescope in orbit, we have other spacecraft headed toward the Sun right now. A joint project by NASA and the European Space Agency, the $550 million Solar Orbiter, was launched February 2020 and is one of the most complex scientific spacecraft to be sent towards the Sun. The Solar Orbiter was sent on a mission to take the first ever pictures of the north and south poles of the Sun. The probe carries 10 different instruments on board, including high-resolution telescopes and other measuring devices. Its objective is to get as close as 26 million miles from the Sun and study the massive fireball at a tilt in orbit, allowing it to view the poles directly, places no human has ever seen before. Solar Orbiter has to withstand incredible temperatures from minus 300 degrees Fahrenheit in the cold of space to over 900 degrees Fahrenheit as it approaches the Sun. Because of this, the instruments on board are protected by a titanium heat shield that has a calcium phosphate coating. But the environment is so harsh that it does not have a camera facing the Sun. Despite this, the Solar Orbiter has taken some incredible photographs and footage on its way to the Sun. On November 18, 2020, the heliospheric imager camera on board the spacecraft grabbed images of Venus, Earth, and Mars. New images of the Sun taken just 48 million miles from its surface are the closest images ever captured by cameras, and they revealed something never seen before. Mini flares all over the Sun, a millionth the size of a regular solar flare, called campfires. It's not clear yet what these mini flares are, but they could be mini explosions called nanoflares, which may help heat the Sun's atmosphere. You probably didn't know that the surface of the Sun has a relatively cool surface temperature of 9,941 degrees Fahrenheit, but it's surrounded by a super hot atmosphere of more than 1 million degrees. And that's not all. It was about 80 years ago when scientists found the temperature of the solar corona is much hotter than the surface of the Sun by 5 million degrees Fahrenheit. The high temperatures of the corona caused it to expand into space as a continuous outflow of plasma called the solar wind. It extends past the planets, forming a bubble called the heliosphere, wrapping around everything in the solar system. But how the Sun accelerates this solar wind and propagates it out to the solar system is a giant mystery. To investigate this and other strange solar phenomenon, the $1.5 billion Parker Solar Probe was launched in 2018 to study the outer corona of the Sun. It will fly very close to the Sun, coming within 4 million miles of the fiery plasma ball. That's 7 times closer than any spacecraft has come before. You may be wondering, if the probe gets so close to the Sun, won't it burn up? The Parker Solar Probe is designed to swoop through the Sun's super-hot outer atmosphere, but in order to survive the high temperature and complete its 7-year mission, it needs to be traveling very fast. so it will swing by Venus a total of 7 times. One of the first images Parker's solar probe took during its close encounter with the Sun shows a streamer of plasma in the outer solar corona. The bright spot below the photo is the planet Mercury. By the end of its mission in late 2025, at its closest approach, Parker Solar Probe will be hurtling around the Sun at 430,000 miles per hour. The front of Parker Solar Probe's shield will face radiation and heat as high as 2,500 degrees Fahrenheit, but the instruments on the other side will be near room temperature. What do you think the Parker Solar Probe will discover? And what do you think the poles of the Sun will look like when the solar orbiter completes its mission? By studying the star that we live with, we'll learn more about other stars in the universe, and we may be able to predict when solar storms will erupt. With everything that we've learned, we still don't know what's inside the Sun, but that could change very soon. If you enjoyed the video, then stay tuned so you won't miss out on our next upcoming video, Real Images from the Solar System.